we're going to go ahead and get started. Thank you to everyone for joining us today. I'm Michael Heap. I'm the Director of Developer Relations here at Congo, and I'd like to welcome you to today's online meetup where we're going to be talking about the new performance testing framework from the Congo Gateway 2.4 release. For those of you that are new here, we take the first part of the meeting to walk through a short presentation and a demo. Paul will be doing the presentation and Wang Chong will be doing the demo. And then we're going to open it up for a Q&A and discussion. And at that point, you'll be able to unmute and turn on your video. But if anything comes up whilst you're watching, feel free to drop the questions in the chat tab at the bottom of your screen. We'll make sure we get to those when we get to the Q&A section of the call. With that, I'm going to hand it over to Paul to kick us off.
Thanks, Michael. So hello, everyone, and welcome again. Just wanted to say thanks for taking the time out of your busy schedules today to be with us here on the community call. We really appreciate you being here. My name is Paul Fisher, and I serve as the product manager for the Congo Gateway. And joining me today is for a technical walkthrough is Wang Chong, an engineer on our Gateway team as well. So with that, let's just jump right into it. Onto the performance testing framework. So I wanted to make this a little bit interactive to start. We'll see how successful it is, but maybe by show of Zoom hands, and I believe there's a button at the bottom of your bar to raise your hand. I want to kind of just poll the audience to see how many of you engaged in some type of capacity planning, maybe to help you understand how many Kong nodes are required for maybe a migration you're doing internally, or if you're gathering some type of information around concurrency. So what happens if I have like X amount of users trying to make X amount of calls per second? At what point does sort of the gateway or your APIs start to break down? So if you could click maybe the thumbs up or the raise hand button. I'm just kind of looking through the audience here. If you've run into these type of scenarios. I got some hearts, I got some hand raises. Thanks for that. Thanks for that little survey. So in version 2.5 of our gateway, we've been incubating a new performance testing framework, which we're excited to show you today. It provides an efficient way of carrying out performance benchmarks on the Congo Gateway. So on our side of the house, in the Congo Gateway GitHub repository, we've integrated this performance testing framework with GitHub Actions to help us, from a maintenance perspective, understand how performance changes all the way down to the PR level. And you'll see here on the slide a sample output from our own internal tests. So with every PR, we can trigger this performance testing framework to show the latency or request per second all the way down to the PR. And this is a really powerful tool for us internally because maintaining the open source gateway requires, a constant trade-off between performance and delivering really rich feature sets. So with this performance testing framework in place, our engineering team has had the ability to start to plot this performance trends over time, and so that we're ensuring that our gateway has a high performant benchmark that's come to be expected by our community. And this is maintained with sort of every commit. So what it means for you is, if you're evaluating how to build the proper environment for the gateway to, say, match your deployment requirements, our goal with this performance testing framework is to help you better understand that and to collect metrics and data to help you more accurately estimate the hardware requirements that you might have and ultimately save you on costs. Or if, for example, you'd like to understand how a particular configuration of the Congo Gateway operates, say with a plugin in a specific environment, this framework could be used as an accurate measurement of gateway latencies. And that's something that we wanted to show you today in our sort of technical walkthrough. So in this session, we'd like to show you how to get set up with this performance framework, get an environment running. We're going to showcase our out-of-the-box tests that we use internally. And at the end of this session, we'll have a Q&A on benchmarking in general. And I'd love to take this opportunity to kind of understand where your benchmarking needs are best served. Today, this performance testing framework has a test that we built out of the box to kind of use internally. So we're continuing to evolve this framework and think about benchmarks and tests that may serve a broad range of our user group as we look to evolve this framework. So I also wanted to mention that all the resources that we'll show today, we will append to our existing doc article on our performance testing framework, so you can kind of get it set up and running quickly and help provide feedback. So with that, I'd like to kind of turn it over to Wan Chung for more of a technical walkthrough of this.
Cool. Hi, everyone.
Go ahead and stop sharing.
Sure. Yeah, my name is Wan Chung, and I work for the core team at Congo. And today I would like to share a session with all of you to actually get hands-on to use the performance testing framework. And as we're trying to be more flexible for just to get on these tools as fast as we can, we are choosing the Docker approach here. So let me actually share my screen first. So if you have your laptop around, you can just follow my command, and we'll get this pretty soon, just a few commands. So we'll be using the Docker image, on Docker image. And since we are using the Docker approach here, so we're also going to mount the Docker socket into the container. And I'll send this command in the Zoom chat, so you can just quickly paste. Okay, so we're also running using the root user, since we need to access this Docker socket, and you don't want to use that in your production, because in this image we're using as nobody, and it's supposed to be more secure than running as root. Okay, so since I already have this image locally, and then I'm already in this container, and the version we're using here is 2.5, and since this is the image you'll be running for production traffic, and we do not have all the development dependencies inside this container. So the next thing we're going to do is to install several dependencies for development. We'll be installing the Docker CLI and also some headers and the compilers to make the test we're going to run happy. So it takes a few seconds or minutes. While this is running, I can also describe the next step. So in Kong, we're using a tool we call Basket. It is like a lower testing framework, and we're using it for unit tests and also into end-to-end tests inside the Kong. And the performance testing framework is also based on the Basket. So for next step, we're actually going to install the Basket framework in our container, because as I just described, this is like a development dependency and it's not included in the core image shift. That's it. Well, okay, so I have all the dependencies, and let's install this Basket. Good. All right, this is lighter than the headers we saw earlier. And then we're actually going to run it because we have all the dependencies ready. And I have this like a template test and I have in the common repo, but in the separate branch. Share the command here. So we're going to clone this common repo, which included all the test pictures. We do not include in our image. We're using this branch I created for this meetup, and it included some of the fixes we have, and also the sample test that we're going to go through later. Other files here, and then we are going to enter this directory. Unlike the files you see in this container, this also includes a lot of like things for development, like the log spec and like the readme files, and also this stuff and this stuff. And those are the spec and T. Those are for testing, and those are not included in our image. So we need to pull this from our GitHub repository. And the command you are going to run for this any based testing is by using the binary we have under bin basted, and then the file you want to run for. And for example, for Congo we use having a unit test, and let's take example the rock spec testing. Yeah, so this is like what you expect from running a test, but this is for just a general unit test, and it's not for the performance test. But it will be very similar if you change this to be 04, which is the perf, include all the performance testing things, and the 03 meetup. And under this directory, we have a new test that we can just see the results. And I keep this running for a while, and while this is running, I'll go to another one and show you the file inside. Okay, 0, 4, 3, sample. So for every test you're running here, it's actually a raw file, and just like the extension name suggested. And so we're going to set up this performance testing framework, like the environment, because it's testing, so you expect the log level to debug. And then, of course, we're using Docker driver here. We can describe like the terms of driver later, but let's just use this API for now. And for every like test segment in Basket, and you have this describe function to describe a like a block. Like it's actually just a closure to include all the like states and the steps you want to set up. You have this description here, and this lazy setup is another function you call to set up the setup call actually. So you get this helpers we call to manipulate the quantities. It will return by the setup function, and then you set up some service and routes. So the test we are testing here is to have two separate routes point to the same service, which the service is something we will set up for you in the framework. It's just Nginx upstream. So it's the performance of upstream should not be the bottleneck of your framework. Then we're also going to have a plugin called Creation ID. It's just a simple plugin that adds certain headers in your response. And this won't be attached to this road 2. It will be attached to road 1. So we can compare the difference of performance with or without plugin. And so let's actually go back to here. So see the results here. And so this is like just a debug block. Just over that. And for each section of test, you'll see the results coming out and using the tool called WK work to show you the request RPS like a request per second, and also the latency. So this is without plugin, and this is with, and we can see there's a slight difference. So actually the difference will not be that much because we're running inside Docker, and I'm kind of running Zoom here, so my computer is overloaded. So yeah, let's go to that part later. So you can get the basic idea here that is that you will have a slightly performance difference with this correlation ID plugin enabled. And this is just a basic idea. So let's go back to this test. So this is just for starting call and stop call and tear down. So for every test, we just copy paste all these parts. And this is a section that actually makes a difference when you see the results. So it is actually just another description block. And in this block, you can just start a node with five threads and 1,000 connections and last for 30 seconds. And it will hit this route port 1 where we don't have this plugin. And then get result and get a result. And in the next section, we'll be into route 2, but we actually have this plugin. And it's also the same thing that you wait for result and you print it out. Yeah, that's the basic idea. So although this is very simple, it's very simplified test, and there's more than this you can do in this framework. For example, you can test between different versions. Let's see from here, because when you start code, you can actually point a version. It can either be a GitHub tag or a doc image or anything you want to distinguish between different versions, and so you can actually test between like maybe different custom images or different commits you made to compare. Then also for the actual capacity planning, you don't want to use Docker driver here because Docker is all running on your local machine, and it will be very flaky based on the workload you're having on your laptop. So we also kind of provide some other drivers. We provide a local driver where you don't want to run inside Docker, so you can get maybe some network like a performance boost without using the bridge network. And also another driver we call Terraform. This is this is a driver you will need to run for capacity planning. So this will just invoke the Terraform. It's going from HashiCorp, and it will spin up the several infrastructure, like the real EC2 instance or like a bare metal instance or a Google Cloud instance, and it will actually run call inside and test the IPS and latency based on the spec select to bootstrap. Because of the flexibility here, you can also add many infrastructure detail here. If you want to have a ELB and having an ASG in your EC2 instance, and that's all supported just by this Terraform module. Yeah, I guess that's it. And Paul has shown the docs for like describing the difference between drivers and how you want to select overs. Yeah, that's all to share.
Thanks for that, Long-Chan. Really appreciate it.
Yeah, that was really interesting. I've been copying and pasting all the things from the chat that you shared. And I think my project this evening is going to be building a Docker image with all of that pre-installed. So it's just a Docker compose up for anyone that wants to go and kick the tires and try this out.
Yeah, definitely. That's actually exactly what we plan to do in the future. And we're going to maybe provide Docker compose file or just like an image based on every release of call. So it's just for development purpose. It's not for like running call. You can use the image to run any performance test or even the real normal like end-to-end test.
Oh, isn't that the beauty of open source? Like you have that on your list, and I'm thinking I want to go and try this out. So I'm going to build it, I can share it, and everyone here and everyone in the community can benefit from that. Yeah, I'm excited to try it. So thanks for showing us. We've actually got some time for questions now. If anyone's got any they'd like to ask, feel free to unmute and ask, or you can drop them in the chat and I will read them out for you. No questions. Wang Chong did such a good job explaining the performance testing framework. There we are. What is the minimum version of Congo SS from which the performance testing framework is supported?
Yeah, that's actually a good question. So, so actually, there's like two different like way of talking about versions. So as you can see here, we're running. I'm not sure on screen, but yeah. So we're cloning the Congo repo and also specify a version we're running the test. So when you clone the version, you have to use the Congo branch newer than 2.5. But that doesn't mean you can only test the clone newer than 2.5. You can actually test any version even before 2.5. So the tool only exists in the 2.5 branch and also master branch of Chrome. But once you get the tools on you can actually use it to test any version of Chrome. Yeah, even earlier than 2.5. But yeah, I don't see there's like a lowest minimum version of Chrome you can test. If you find one, you can tell me. But I think it's like a unlimited. Yeah.
Excellent. And I learned something then. I thought it was only 2.5 onwards. But yeah, it turns out you can test all the versions as well. It's just that the tooling only comes from 2.5 onwards. Any other questions?
One thing I'm interested in learning too from everybody is we have this example, latency request per second test as a part of our meetup prep. But I'm kind of curious to learn what other kind of benchmarks are most impactful to the audience here in solving their challenges, internally, whether it be costing or concurrency or any kind of information around benchmarking that's going to most help you. We could potentially build some out-of-the-box tests for it.
One that I've been quite interested in is actually the number of consumers. So what is the performance when I've got one consumer, 10 consumers, 1,000 consumers? Like, does it start to drop off at any point? So if I want to map my users to consumers, like what is the performance impact of that? So that's what I'm thinking about building out.
Yeah, that's a good point. And also, like from the developer side, we also want to know like the number of routes and service, and yeah, also the like targets and like upstreams number with regard to the performance.
So is there anything that anyone on the call would like to test, whether you do it yourself, whether it's an idea for us to pick up and write the implementation for you? Like what would you like to measure the performance of? We've got routes, services, consumers. Like what's on your mind when you're trying to scale?
Hi guys. So generally, while we run some performance tests at Dream11, what we check is the latency that a plugin that we have written introduces. So that is one thing that we check very closely. And it generally what happens is when you start writing your own plugins and as the layers of plugin keep adding on, the latency increases. But we always keep a check that what is the trade-off and how much is the latency increasing. But I think this is already there in this performance testing framework. That is something we can already measure. So yeah, that is one thing that we generally check.
Thanks for the insight. Interesting that it's primarily plugins that you write yourself.
Yeah.
I see there's a message from Shivag as well about mostly the plugin overheads. Can you tell us more about that? Are those in-house plugins, or are you evaluating the ones that Kong and the community provide?
Mostly the in-house plugins, as Anuj mentioned, we actually work at the same company, same team. So yeah.
That would explain why you gave the same answer. At least you're all aligned.
Yeah.
We have another question. Can this framework be used for Kong on Kubernetes?
Yeah, that's a good case. Actually, I've been asked by this question from our colleague as well. So So the short answer is no for now, but this is like something we are planning to do because with Terraform, you have the Kubernetes provider and you can just spin up the compose and also like the workloads inside of the Kubernetes cluster. And from the up level, you just see this as a con service and like a load service, and this will be just transparent to the framework. And it will just depending on what you implement using the Terraform driver. It can be, yeah, you can also like spin up this workload on like a ECS, maybe some like a hosted Kubernetes solution, and also maybe also on your local like, Minikube.
So if I heard that correctly, like we can't use it for Congo on Kubernetes as a performance testing target. But am I understanding it correctly that if we run the performance test, say locally or in Docker or on EC2, like we might not get exactly the same request per second, but the story should be very similar. Like if the requests take 20% longer with a plugin, is that roughly 20% longer if we deployed to Kubernetes as a runtime as well? Or is that not really how it works?
Yeah, that thing, and also actually you can also spin up the Kubernetes cluster using the Terraform driver, but not the Docker driver which we are like demoing today. With that thing, you can actually run the con inside of Kubernetes and see what it performs with regard of your infrastructure setup. So, but this is not like supported right now, but it's very easy to implement, both on our side or from the community side.
Got it. If someone wants to take a stab at implementing that, like if you want to try it out, I'm sure we'd be able to get the engineering help to work with you on the pull request. Like, so everyone's going to benefit from that. Any other thoughts or questions? Going once, going twice. All right. In which case, we're going to wrap it up. Thank you for joining us today, everyone. Thank you, Wang Chong, for the demo, Paul for the presentation. Just want to remind you all that our next call is on September the 14th, and we hope to see you there. Have a great day, morning, afternoon, or evening, everyone. Cheers.